Hey guys, welcome to Unit 15. Our topic today is use substitution with power rule. So pause the video and try the warm-up. So for the warm-up, it's asking us to find the derivative of this function 3x to the 4th plus 2x minus 1 to the 5th power. So we are going to be using chain rule here. So what happens is the 5 comes in the front and you're left with 3x to the 4th. You leave whatever is inside as it is, and your power goes down 1 because it's 5 minus 1, which is 4, times the derivative of this inside, this whole inside, which would be 12, 3 times 4 is 12, x to the 3rd plus 2, right? You can actually multiply 5 times 12x cubed plus 2, or you can just leave it like that. It is fine to leave your answer in this form. So now part B is asking me to integrate what my answer was, right? And how would I get this? So basically the answer to this would be 3x to the, it would be what? Since I already have the answer, the integration and derivatives are inverses. So my integral of this would be 3x to the 4th plus 2x minus 1 to the 5th plus your C. So what if I never showed you the first part? How would you have done this, right? How does this happen? For this, we need to do, we can think of it as a composite function. We think of a composite function as a single function that contains other smaller functions inside it. Since there is no product or quotient rule for integration, we must use pattern recognition. To perform the chain rule in reverse. So if f and g are functions such that f of g of x and g prime of x are continuous on that interval, then we are going to be using this form today. Okay, so that's kind of your chain rule, and this is what we are going to be doing. If we rewrite the original integral in terms of u, and we're going to take the derivative of that, which will give us du, we will call it u substitution. So we're going to take that function, we're going to pick our u to be the g of x function, and then we're going to find its derivative, which would give us du. So this is what we are going to be doing is, once we do u sub, we're going to set up the integral into something simpler in terms of u. The main challenge is to think of an appropriate substitution. So along the lesson, I will be giving you tricks or hints to determine what you are going to be picking for your u sub. And let's get started with the first one. So in this one, you look for terms that are in parentheses. So if I say that let my u be, so let u equals x squared minus 5. So you look for something that has an exponent or your higher degree. So now I'm going to take the derivative. So if I'm differentiating with respect to x, it will be du equals 2x, the derivative of 5 is 0 dx, right? So now you want to look at what you have and what you want to replace with. So if you look at this, I'm just going to highlight it. You have x squared minus 5 is u, and you want to replace 2x dx, which we have 2x dx here, right? So let's replace that and pick another color. In place of x squared minus 5, I am going to write u to the 4th, the integral of u to the 4th, and in place of 2x dx, I am going to write du, right? This is much simpler integral in comparison to what we were given. So what are we going to do is just integrate by the rules of integration, which would be what? U to the 5th over 5 plus c. And then you must substitute back. Once you're done taking the integral of this function, you must substitute back and write in terms of x. So your u was what? x squared minus 5 to the 5th power over 5 plus c. So this is how you do it. You basically look, your final answer must be rewritten in terms of x. Okay, so now when you have some like a rational function here, so what would you pick? Pick a term or set of terms which has a higher exponent. So you have x in the numerator and x squared in the denominator. So I'm going to say let u equals x squared plus 3. So I'm going to differentiate with respect to x. So it will be du equals 2x dx. Right? So now just think about it. What you have and what do you need to replace? So I can replace the x squared plus 3 by u. How about x dx? I only need x dx. I have that extra 2 in there. So can I not rewrite it as du over 2 or 1/2 du? Right? So I'm going to replace my x dx with 1/2. Oops, I'm sorry about that. I'm going to replace my x squared with u, and in the numerator I would have 1 over u times, I'm going to do du over 2. Right? Can I not rewrite it as it's same thing as 1/2 2? So can I factor out the 1/2? And I'm left with 1 over u du. So what gives me a derivative, or what function's derivative is 1 over u? It is actually ln. So it will be ln of u plus c. Now again, your final answer should be in terms of x. So I'm going to substitute x with what? Sorry, u with x squared plus 3, and that's your final answer. Okay, I'm going to do a few more, and actually since we are doing these for the first time, it's just telling you what your u is. So let's determine ourselves also, is that the u you would have picked, or how to identify that u. So if you look at this integral, we talked about picking the higher, looking for something that's in parentheses or the higher exponent. So negative 3x to the 5th minus 1 is raised to the 5, right? So I'm going to make that u, which is given to us, and what would be du? So I'm going to take the derivative. It will be negative 15x to the 4th dx. Yes? So now again, think about what you have and what you need to replace with. So I have negative 15x to the 4th dx. I can replace that with what? Du. And negative 3x minus 1 can be replaced with what? U. So it will be u to the 5th du. So use your power rule. So it will be u to the 6th over 6th plus c. Substitute back your u with your x. So it will be negative 3x to the 5th minus 1 to the 6th power plus c. Yes? Okay, the next one again. Look for something that's inside the parentheses, which it's already given to you. Your u is this. So your du is going to be, take the derivative of it. It is negative 16x to the 3rd dx. Yes. Now again, look for what you have and what you need to replace. So what you have is, so this is going to get replaced with u. And then you have negative 16x cubed dx. So that's what you have. So I'm going to do u to the negative 5th times du. Right? The integral of that. So which would be, I can do this as what? U to the negative 4, negative 5 plus 1 is negative 4 over negative 4 plus c. Replace back your u with your x term, which is negative 4x to the 4th minus 1 to the negative 4 power over negative 4 plus c. Let's do one more. Oops. Okay, so here I actually want to do 3 and 4. So here again, see, what is, I said look for something that has a higher exponent and inside the parentheses. So our u is picked to be that. And what would be du? Differentiate with respect to x, it's going to be negative 8x to the third dx. So again, think about what you have and what you want going to replace. So you already have, if I was to set up the integral, you have u as, it will be 1 over u to the fifth, right? And negative 8x cubed dx can be replaced, this whole thing can be replaced with du. So just like derivatives, or in the past we used to simplify it a little, so we're going to simplify it here and we're going to rewrite it as u to the negative 5 du, which would be u to the negative 4 over negative 4 plus c. Substitute back your u, which is negative 2x to the fourth plus 5 to the negative 4 power over negative 4 plus c. Okay, can I rewrite this for number 4? Can I rewrite this as to the 1/2 power? Yes. So again, it's something inside the parentheses, so I am going to make my u equals 4x squared plus 9. So what would be my du? My du is going to be 8x dx. So again, think about what you have and what you want to replace with. So you already have u, so this can be replaced with u, but I have only x dx. I don't need that 8. So what am I going to do? I'm going to get rid of that 8 by dividing by 8 on both sides. So I'm left with du. I can write it as 1/8 du equals x dx, right? Now I'm going to write this integral in terms of u. So it's going to be, in place of 4x squared plus 9, I'm going to write u to the 1/2 power, and then it's 1/8 du. I can pull out the 1/8 and I can take the integral of, let me do it in 2 steps, right? This would be what, 1/8, 1/2 plus 1 is 3/2 over 3/2, which I can simplify it plus c. If we simplify that, that would be 2 over 24, which is same thing as 1/12. So 1/12, and I'm going to substitute my u with x, so it's going to be 4x squared plus 9 plus c, or if I want to clean it up a little nicely, over 12 plus c. Okay. Oh, I forgot the 3/2. Yeah, be careful about that. So that's basically it, guys. So finish up the remaining and please ask questions if you have any. Good luck.